So now I will take you through to another type of data structure in R, which is matrix. So matrix is quite similar to data frames in the sense that it also allows you to create a structure with two dimensions. That means you can have rows in a matrix and you can have columns in a matrix. The major difference between a matrix and a data frame is that matrices can only enable you to save elements of the same type. Uh, so with that, I will just take you through to some of the code which I've already written to save some time. So I'll quickly go through these lines of code and just explain you in the process. So this is what you've already seen. I've got 4 vectors: name, city, salaries, tax. This is the example which we've been doing since the last few videos. And there are different ways of creating a matrix. So one of the ways is by using the cbind function. And cbind function basically means that we want to bind the information inside the matrix in columns. And by that I mean that if you have specified different vectors which you want to bind, and in this case we have a vector of salaries and a vector of tax, what the cbind function will do is that it will create a column of salaries and bind it to another column which it will create for tax. So in this way we will have a matrix of 2 columns. One is employee salaries and the other is employee tax. And because each of these vectors have 4 elements, therefore the resulting matrix will have 4 rows associated with it. So cbind takes these 2 vectors and stack them with each other in the form of columns. Now I told you early on in this video that a matrix can have elements of same type. So we can see that employee salaries have these numerical values and employee tax have these numerical values. That's why we can use these 2 vectors to create a matrix. So once we have got this matrix, it will have one column with the name of employees.salaries, another column with the name of employee.tax, but we don't have at this point a name associated with each of the 4 rows. So in order to resolve that, what we've done is that we've used this row names and passed an employee statement. So it's row name employee statement, so that's the matrix, and then we are passing this this vector which we have created initially in the very first statement. And what we are saying in this statement is that okay, we've got 4 rows, and name all of these 4 rows using the values of this vector. So the first name, the name of the first row will be the first element of this vector, which is Alice. The name of the second row will be the element of the second value, which is Bob. So the best way to show you is just by executing this. Hopefully when this line will execute, we'll see the exact matrix, and then at the very end we'll inspect the structure of this matrix. So let me start by creating these 4 vectors. I'll select these 4 lines, execute them, and hopefully the 4 vectors are going to be created. And then now when I'll execute this statement, it will create a matrix with the name of employee statement, and when I'll execute this line, it will give the name to each of the rows. And finally I'll run this statement as well so that we can see the exact structure, not the structure, the exact matrix, the contents of the matrix. Let me run this, and now we can see that it has created a matrix with 4 rows, 2 columns. The 4 rows are named as expected: Alice, Bob, John, and Mike, whereas the 2 columns are named after employee.salaries and employee.tax. So I'll clear the console and just execute this very last line just to see the structure. And when I see the structure, I can see that it is indeed telling me that it has 4 rows, 1 to 4, and 2 columns, and it is showing these contents just in a single line. So that's pretty much the structure. Also, it is telling me about dimension names. It is telling me that there are 2 dimensions, and then it is also telling me the first dimension is the 4 rows with the name of Alice, Bob, John, and Mike. The second dimension consists of 2 columns: employee salaries and employee tax. So that's how you can create matrix. That's one of the ways of creating matrix. When you take 2 vectors, you combine them, you bind them together and stack them together in columns. But there's another way of creating matrix, which is by using rbind function instead of cbind. So here you can see rbind function, and we are taking the same 2 vectors, and now what we are hoping is that it will take the first vector and create a row using this vector, and then underneath the first row it will create a row of employee taxes, and the name of the first row will be employee salaries. The name of the second row is employee tax, and in order to set the names of the columns, and hopefully there will be 4 columns because there are 4 salaries and 4 taxes, we will use in a very similar fashion column names rather than row names function, and we will use this vector to name each of the columns after the name of all the employees, and then we can see the content of the statement, and at the very end we'll inspect the structure. So I will, without wasting any time, just execute these lines of code, and we can see that it has created 4 columns, 2 rows. We can see the names of each of the employees as column names, and we can see the names of the rows as well. Just as a final step, I'll run this last statement just to see that we've got the structure as we were expecting, and we can see that it is telling us that there are 2 rows, 4 columns, and these are the contents, and it is also telling us that there are 2 dimensions. The first is employee salaries and tax, which is the row name, and the second dimension consists of 4 columns, and these are the names of 4 columns.